Hi all, I'm Shebin Sam Abraham of registration number URK18CS277. So today I'm going to explain the 10th experiment on System Software and Compilers Lab, and that would be intermediate code generation. So today's aim is to write a program that converts HLL, high level language code into intermediate format, 3 addresses code. So here, the compilation process can be divided into a number of subtasks called as phases. The different phases are lexical analysis, syntax analysis, intermediate code generation, code optimization, code generation. Now, we'll just go for the intermediate code generation. Once the syntactic constructs are determined, the compilers can generate object code for each construct, but the compiler creates an intermediate form. It helps in code optimization and also to make a clear-cut separation between machine-independent phases and machine-dependent phases. One form of intermediate code is a parse tree. A parse tree may contain variables as the terminal nodes, as binary operators will be having a left right branch for operand 1 and operand 2. Another form of intermediate code is a 3 address code. It has got a general structure of A, B, or C, where A, B, C can be names, constants, temporary names, etc., and can be of any operator. Postfix notation is yet another form of intermediate code. So let's go directly in the algorithm to so you can learn more on the program. Get an expression as input, scan the statement from left to right, frame new statements such that it performs one operation at a time. It performs one operation at a time, either assignment or arithmetic or relational operation. So that the algorithm would be get an expression as input, scan the statement from left to right, frame new statements such it performs one operation at a time, either assignment or arithmetic or relational operation. Display the new set of statements. So you're getting an expression, you're typing in an expression. So it scans from the total from left to right, frames as it performs one operation. So what all perform, like addition, subtraction, multiplication, divisions, what all arithmetic operations has been given, it depends upon it. If it's assignment or arithmetic or relational operation, it checks on how many operations are present and which should be given the high priority, and then it depends upon it displays a new set of statements. So this is an algorithm. Let's go directly into the program. So it's a Python programming. So it's like import re. So j is equal to 1 and y is a set of variables that has to be entered. You're opening an array over there for y. So OP is an array, and you're putting arithmetic signatures plus, minus, division, and multiplication. So these are into the operation. These are into the OP variable set. And then x is equal to input, enter the expression. So enter the expression, asking the user to enter the expression. M is equal to re dot split. So here means once you enter the expression, it splits the both. It splits the whole formula, the whole statement that you have given, that is re dot split plus minus division into comma x, and then define compiler where word in M, if word is in OP, if word is in operation stack, is in operation area, then y dot append join M 0 to 3, M dot pop and out. So you are it's getting arranged on a stack. So and then it's getting arranged, and then taking each of the variables, like if it's a constant, if it's like a plus b minus c, so a b c gets divided, and plus minus division gets divided into both stack tables. It gets, like as we know, like arranging it in stack. So it gets stacked. It's each variable gets popped out. If it's a variable, if it's a constant, or if it's a variable, or if it's an arithmetic operation, each gets popped out and goes into its perspective stack. So m of c is equal to 10 plus string of j. So j plus 1, j plus is equal to 1. So once the first string is done, it goes to the second, then it goes to the third. So first string, it's arranged at its correct position, and then it goes to second. So a gets arranged into variable, then it goes to a sign, that is plus. Plus goes to the arithmetic operation, that is op, and then so it gets split into, it starts splitting till the end, till j stops working, and then it returns m and j. Where length of m is greater than 1, mj is like comparing m is equal to j, k is equal to length of y dot reverse. So it checks for the length of the y. So y before we gave it as an empty set here before. So now the variable gets stored into y. You're checking the length for y and then you're reversing it, arranging it in the reverse order. For I is in range 0 to length of I. So if length of y is 3, means from 0 to 3, if the range is, for I is the range, print temp plus string of k plus is equal to plus of yi. K minus is equal to 1. So once it's getting arranged in reverse order, and then they check for the range, and once they check for the range, they starts printing in reverse order. So it will be like, yeah, it's okay plus minus. So now it starts reducing from the top, it goes down to the bottom. It starts reducing, minus minus, it keeps on reducing, and then starts removing from the top variable because it should be printed in reverse order. So let's go directly into the output, and yeah, let's go directly into the output. So here you're entering the expression, that is a plus b minus c minus d. So temp 3 at the topmost, it will be temp 2 minus d. For temp 2 it will be temp 1 minus c. For temp 1 is equal to a plus b. So here ends my 10th program on intermediate code generation for System Software and Compilers Lab. Thank you.